All right, so section 2.2, part 2, and we're looking at a problem about cost and revenue. Forgot to start the video, so I'm just trying to introduce it. So the company has two different kinds of costs. They have a revenue that they're going to take in at $4 a shirt, and we want to find a graph of the cost and the revenue. All right, let's start with the cost. Let's let X be the number of shirts. Okay, the number of shirts that we sell, whatever it is. Number of shirts. Let's start with our costs. What is the variable cost? In other words, the cost that changes depending on how many shirts we make. How much does that cost?
It's just the cost of how much it's like $1.50.
Yeah.
How much it costs.
So the variable cost is $1.50, but that's per shirt. So how would we represent a cost of $1.50 per shirt?
Just some letter.
So X is the number of shirts. So what would we put right here to represent that? Yep.
$1.50 or 1.5x.
So the costs are going to be $1.50 per shirt, plus there's another cost. What's the other cost we have to take into account?
The rent, which is $200,000.
Yeah, like whatever the $200,000 is, like the rent for the building, and that you don't pay that per shirt. Okay, you just pay $200,000. That's it. Okay, so there's the money that the company spends. Okay, that's money that leaves the company. Now I want to write a formula for money that comes into the company, and that's going to be revenue. So cost and the revenue. How much does the company take in per shirt? Yep.
$4.
Yep, $4. So what would
$4.50.
that's the profit per shirt, but it's not the money they take in. You get the difference? Yeah. So how would you write the money that they take in per shirt in that box? Yeah.
Would it be 1.5x minus 200,000?
No, revenue doesn't even, you don't even have to look at costs. It's just money, like if they had a sale and they, count how much money's in the cash register after they sell the shirts. So you don't have to even look at costs. What would go in that box? Yeah.
It would just be 4x.
Yeah, it'd just be 4x. Okay, and I agree, not all that money is profit, but that's the money, like if you count it in the cash register, what they would have. If you look at the difference between the two, that would tell you the profit. Okay, but that's all they want for that one, just writing those equations. Let's graph it. So first we gotta turn the calculator on, type them in. 1.5x plus 200,000. Yep, and 4x. Okay, x is the number of shirts that we sell. Can we sell a negative number of shirts? No. So we shouldn't be looking at negatives. How many shirts can we sell? There's really no limit. I heard somebody earlier say something about like 50,000. Let's start with that. Let's say we sell 50,000 shirts. Y is either the cost or the revenue. Both of those are always positive. If you count the money in the cash register, it's going to be positive. If you count up how much money you spent and gave, to the company that you had to pay to rent the house or building from, it's a positive amount of money. But what's the y-intercept on our cost?
Are you talking about like how much it costs to make them?
Well, in that equation, what's the y-intercept?
200,000.
Yeah, the 200,000. So that means on my graph, I need to go to at least 200,000. And I should probably go even a little higher. Let's maybe go to like, I don't know, 400,000. I go a lot higher. I'd like double it. Let's go to like 400,000 because we're just dealing with such big numbers. Okay, that's the graph of my cost as I make more and more shirts. That's the graph of my revenue as I make more shirts.
Across,
What's starting to happen?
it's about across at like 80 then.
Yeah, it's the revenue is starting to catch up. So the money that you're making is catching up to what you spent. And eventually, they are going to cross. But we need to look further to the right. Let's try like 100,000. I'm just trying to see if I can tell where they cross. Yeah, that's going to be good. So where on this graph do they actually start making money? Like, no, you don't have to give me a number, just like explain where you would look. Yep.
Where they intersect.
Yeah, if you look where they intersect, that's what we call the break-even point. Okay, where the cost and the revenue are the same. That's the point at which the company has spent the exact amount of money that they've taken in. At the break-even point, your profit is zero. You spent $1 million, you made $1 million. Now you broke even. When you get beyond the break-even point, now you're making money. So we just answered that question. If you're looking at a graph, where's the break-even point? It's where they cross. So what I want to do is figure out the number of shirts that we have to sell to break even. Well, we already had a graph, so let's just look at that first. So we're looking for where these lines cross. Can someone remind me how you find where these lines cross?
Second calc.
Yep.
Intersect.
Intersect. And then it just asks you to pick a point on each graph. Doesn't matter. Guess doesn't matter. And there you go. Thank you. So how many shirts do we have to make to break even? Yeah, 80,000. If we make 80,000 shirts, it's going to cost us $320,000 to do it. And if we make 80,000 shirts, we're going to make $320,000. So the cost and the revenue are exactly the same. If we make more than 80,000 shirts, now we're making money. We're beyond the break-even point. Let me just move that in case you need to copy. Okay, so the way that we just did it there, that's graphically. We just found where they cross. Let's see if we can get the same answer with algebra. So keep in mind, break-even point, cost, and revenue are equal to each other. Cost equals revenue. To find the break-even point, take your cost and set it equal to your revenue. What was the formula that we had for cost again?
1.5x plus 200,000.
Plus 200,000. Right? And what was the formula for the revenue?
4.
4x. Okay, so subtract 1.5x to the other side. So we have 200,000 equals 2.5x. And how would we get rid of the 2.5? 2.5. Yep, so take 200,000, divide by 2.5, and hopefully we get 80,000. And we and that's 80,000 shirts. So in this case, solving it algebraically or graphically, either one of them really takes a long time. And that's all that was left in that section, 2.2. So any question on how to find a break-even point, graphically or algebraically? quadratically, I already did. That's what I did there. All right. So the last thing we'll look at, I think you'll find it mostly review from Algebra 1. Maybe some things you might not remember completely, but that's why we're going to review it. Is how you solve like basic linear and a little bit more advanced when we get to quadratic equations. So remember that when you are solving an equation, in order to be an equation, it needs to have an equal sign. Is this an equation? No. If somebody said solve, you can't solve that for x. You can solve that now. Okay, but it has to have an equal sign between an expression on the left and an expression on the right. So I used the word solve. I didn't really explain what that meant, but what solve means is to find the value of x that makes that equation true. So in that case, if you solved it for x, what would x be? 1. Yep. X would be 1. Okay, so to solve an equation means to find the value of x that makes the equation true. Now, some equations, when you solve them, they're always true. Like you can't find a number that would make it false. This equation right here is called an identity. I don't care what number you plug in for x, 2, 6, -3, any number would work. Does anybody see why this is an identity? Anybody see what would happen if you did out the right-hand side?
Wouldn't that be the same equation on both sides?
It's the same expression on both sides. Yeah. So you'd end up with 3x plus 2 on the right side. If you have an equation with the same expression on each side, that's called an identity. Because there's no way to plug in a number that would make it not work. Most equations aren't like that. Most equations are more like the one up above. You can't plug in any number for x to make that one work. That type of equation is called conditional. Conditional usually means that there is a certain number, sometimes more than one number, you can plug in to make your equation work. So in this case, what would be the value you could plug in for x that would make that true? Yeah, 5. That's the condition that makes the equation true. You need to plug in 5 for the x. If I ask you to verify if a number is true, or verify if a number works in an equation, that means to plug it in and see if you get a true statement. So I might give you an equation that we don't know how to solve this right now, okay, because it's a cubic. We can do quadratics if you know the quadratic formula, but we don't know how to solve cubics. I'm not asking you to solve it. I'm telling you that one of the answers is -2. I just want you to check it. Okay, so to verify or check that it's a solution, plug it in and see if you get a true statement when you're done. So how many places do I need to plug in the -2 in the equation up above? Yeah, there's 2 spots to plug it in. So -2 cubed minus -2 plus 6. And I'm going to put a question mark because I don't know. Does that equal 0? That's what I'm trying to figure out. What's -2 cubed? So a negative times a negative times a negative is a
Oh, right. Negative.
negative. And what's minus minus 2? What does that turn
Plus
into?
2.
That's a plus 2. Plus 6. What's negative 8 plus 2?
-6.
And what's negative 6 plus 6?
0.
Okay.
So is it?
Is that a true statement?
Yes.
Yes.
Yeah. Because it's a true statement, that means negative 2 is a solution, and we verified it through those steps. If you ended up with something like 0 equals 3, then you either messed up your arithmetic or the number they gave you to check was not a solution. Any question on how to verify if a number is a solution?
So just to verify, it has to come up to 0?
No, it could say like equals a different number. The key is just whatever you get here has to be the same as what you get there.
So 1 equals 1.
Yep, that would work. Yep.
But like 3 equals 7, that's not.
Nah, that would mean whatever they gave you didn't work or you made a mistake checking. Yeah. Got to end up with a true statement. Same number on both sides. In this case, both numbers were zeros. All right, so the simplest equation that we usually solve with algebra is a linear equation. So a linear equation basically has that format: ax plus b equals 0. No exponents on the variable, no letters in the bottom of a fraction, no square roots for variables, just simple variables. There's no exponent there written, but what is the exponent if they don't normally write it? Yeah, it's always, you can pretend like there's a 1 there if you want. But that's a linear equation. Okay. This one doesn't look exactly like that one, but it could. If you do everything out, it would eventually look just like that. So let's see if we can solve this one. What would be my first step to solving that equation? Yeah, we got to distribute here and here. What's 2 times 2x?
4x.
And 2 times negative 3?
-6.
6. 3 times x?
3x.
3x. And positive 3 times positive 1.
3x.
Okay, so that's your first step, distribute. Now, does the left-hand side have any like terms?
Yeah.
Yeah. Let's combine those. What's 4x and 3x?
7x.
And negative 6 and positive 3.
-3.
Yeah, negative 3. All right, so it's getting smaller. What would my next step be?
Get all the x's on the same side.
Sure, put all the x's on the same side. And how do you want to do that?
Subtract 5x from both sides.
Yep, so you could subtract 5x from both sides. And what else could we do at the same time?
Add 3.
Yeah, we can put the 3 on the other side. This saves us having to write it again if we do those 2 steps at once. Okay. What do we have on the left side now?
5. No, sorry. 2x.
2x, yeah. And then the right side
Yeah.
is 5. So then divide by 2. I wouldn't worry about a decimal. I would leave it just like that. X is 5/2. All right, so that's solving a linear equation. Any questions on that one? All right, so one type of problem that will come up that has linear equation is absolute value. All right, so to solve an absolute value equation, it's probably something you did in Algebra 1, might be a little rusty, so we'll talk about it. First of all, you'd be given a problem that looks something like this. Like absolute value of 2x minus 3 equals 4. The first step is to isolate the absolute value. That means make sure that this part is by itself and there's nothing else next to it. What would be an example of something next to it? I don't know, something like that. Having an 8 plus in front of it. If you had an 8 and then a plus, you don't want that plus 8 right there. You have to put that plus 8 on the other side to get the blue box by itself. If that was the problem, how would you move that plus 8 to the other side?
Subtract.
Yeah, you just subtract it and then it would be gone, and then you'd have to do 4 minus 8. Okay, so once that absolute value is by itself, we're going to split the problem into 2. The reason we split it into 2 is that's going to get rid of the bars. I'm not actually going to go through and solve the whole thing, but I'll just use it as an example. So what I usually do is I draw 2 lines like that to show that I'm going to split it into 2 problems. And it says the first equation is the same as the original, just take out the bars. So for this one, it would be 2x minus 3 equals 4. That's one of the equations you have to solve to get the answer to that problem. So literally copy down the original, just take out the bars. The second equation, you're going to do the same thing. Copy down the original without the bars, but make the number on the other side opposite. That's what negate means. Make it the opposite. So copy it down, take the bars out, but make that number on the other side opposite. 2x minus 3 equals negative 4. If I was going to keep going, those would be the 2 equations that it splits up into. Okay, we're gonna do one, and I'll actually do it all out. I don't want to do that one because it's not nice answers. So. Right, let's see if we can solve that one. Okay, so first question, is the absolute value bars by themselves on the left side? What do we think? Yeah, really? Oh, I'm sorry, 8?
Yes.
Yeah, absolute value bars are already by themselves. So let's split it into 2 problems. Anyone think they could tell me the first equation that would split up into? Yep.
2x plus 3 equals 5.
Perfect. Now you could solve it right now. I like to do the other, just set the other one up first.
2x plus 3 equals negative 5.
Yep. 2x plus 3 equals negative 5. And how would you solve the one on the left?
You subtract the 3 on both sides.
Okay. So 2x equals 2.
Then divide by 2 on both sides.
Divide by 2.
Would it be?
Yep, x would be 1. Or, now we have the other one, and it's the same steps that you just used. Subtract 3 and divide by 2. Negative 5 minus 3 is going to be negative 8. Divide by 2. And what's negative 8 divided by 2?
4. Negative 4.
Yep, negative 4. So generally, absolute value problems are going to have two different answers. Okay. Any question on it? That's how you do it. You split it up. Okay. I think I'm going to skip that one. Let's do. Okay. So the last kind of equation we're going to look at is a quadratic. When you have a quadratic, what's the highest exponent in the equation? Like in a linear, the highest exponent was a 1. In quadratic, it's higher than 1. It's a 2. Okay? And it looks something like that. ax squared plus bx plus c. It is important to understand where the a, the b, and the c are. The a is in front of the x squared, the b is in front of the x, and the c is the constant at the end. I was going to ask you that. But, well, one way to solve a quadratic, if the numbers work out nicely, is to factor it. What's the other way? If you can't solve a quadratic by factoring, you have to use a different formula. Does anyone remember the name of it?
The quadratic formula.
Yep. So we're going to do the quadratic formula as the last problem we do. This one we're going to do factor. So let's see if we can factor this one. So this isn't what I'm doing right now. This isn't meant to be like a full flat factoring lesson. Okay, in Algebra 1, I'd probably spend like 2 or 3 days on teaching how to factor, because it just takes a lot of practice. Okay, but I'll go through one just to kind of hopefully refresh how to do it. All right, so when you are factoring, what's the first thing that you usually write down right below it? It doesn't matter. You don't even have to look at these letters and numbers. If you know you're factoring, you should always write these down. Anyone remember the first thing you always put down to factor something? Yeah?
Parentheses.
Yeah, you need to put down your parentheses. Okay, 2 sets of parentheses. So regardless of what numbers that are up above, start with that. Okay, what goes in the first 2 parentheses is something times something that gives you 2x squared. Can anybody think of what times what is 2x to the second power? Yeah.
2x.
Perfect. 2x and x. And now when you're factoring and you have a positive in the middle and you have a negative at the end, that tells you what 2 signs kind of go here. Does anybody remember how to look at those 2 signs and figure out the 2 that are going to go down there? No? So if you've got the middle, you've got the constant, and then you've got
Is it negative negative?
let's see. Let's take a look. So if you have a positive in the middle and you have a negative constant, that means you need to multiply something times something to get a negative number. What does that mean your signs would have to be? A what?
Positive and negative.
Yeah, it's a positive and a negative. Let's say you had a negative and a positive. Negative in the middle, positive at the end. Does anybody remember what these signs would be? Yep, because negative times negative gives you a positive. And when you combine 2 negatives, you get a negative. Yep. How about if we had a negative and a negative? It still has to be a positive and a negative because you have to multiply 2 things together to make a negative for the constant. And the only one I'm missing is a positive and a positive. And anybody remember what that is? Yep, 2 positives. Okay, so there's a chart that would hopefully kind of remind you how to factor if you don't remember, at least to get the signs right. So this one is positive in the middle, negative for the constant, positive, negative. Now, those are just the signs. I'm not saying it's exactly that order. It might be a positive and a negative. I would try negative, positive in this one. If you get them wrong, you're going to have to switch them at some point. That's all. But I think negative, positive is probably the way to go. Now you need a number here and a number here, so that when you multiply them together, you get 3. How about Zach? What are two numbers that multiply to give you 3? Zach. So what would be two numbers that are going to multiply to give me 3?
3 and 2.
That would give me 6. Yes.
Oh, 1 and 3.
1 and 3.
Too fluffy.
Okay? So 1 and 3 makes a difference which one we put where. I will try them in the order you suggested because I know it's right. So it's a 1 and a 3. Let's check it. What's 2x times x? We got that. What's 2x times 3? How about Brett?
6x.
6x. What's negative 1 times x? Yes.
Negative
Negative
x.
x. And what's 6x? Minus 1x.
5x.
5x. That's exactly what we wanted in the middle. And negative 1 times 3 is negative 3. Okay, so we factored that perfect. Okay, now, once we factored it, that's the hard part. This times that is going to give you 0. What's the only way you can multiply two things together and get 0 as an answer? Well, if they were the same, like 4 times 4, those are the same, but that doesn't give me 0.
0 is at least one.
Right. If you're multiplying two things and getting 0, one of the things you're multiplying has to be 0. Either what's in the first parenthesis is 0, or the second parenthesis. Now it's kind of like absolute value, and you've got to solve each equation. If I solve the one on the left, what would that? Yeah, you could just sign out. You have sports. Yeah, just sign out, and then you're good. Does anyone see what x would be for the one on the left? Yeah, 1/2. Perfect. Good job. Does anybody see what it would be for the one on the right? Negative 3. Yep. And that's one way you can solve quadratic factor. The last problem that we do is going to be one that you cannot factor. And yeah, just sign out. You're all set. What did somebody said it earlier? The other method besides factor?
Quadratic formula.
Yep, quadratic formula.
Hi, Wyatt.
Bye, William.
I'll miss you.
Okay.
Good luck. Have a good day.
Thank you, everyone.
See you in a week.
All right. Hopefully you are somewhat familiar with that at this point, but if you're not, that's the quadratic formula. The part underneath the square root, that's called the discriminant. Not overly important for this lesson. What's important is the whole formula. Now, remember the A, the B, and the C. Those come from here, here, and here. So they're the numbers in front of x squared, x, and the constant, but it has to be equal to 0. If it's not equal to 0, well, make it equal to 0. We'll just fix that first. Okay, so before I scroll down, I'm going to scroll down, but the formula is going to go off the screen. Does everybody have the formula? Okay, probably a formula I would put on the reference sheet if you're going to make a reference sheet for the test, which you can.
Is that a negative B?
That's a negative B. Yeah. Yep. Let's try.
It's in your right, right? I know. Your pencil.
All right, your pen.
Yeah.
Okay, I want to solve this one. Okay, I'm going to give you a hint. It doesn't factor, so we're not even going to try to use quadratic formula. If you did, you just get kind of frustrated because it wouldn't work. So what's the first thing that I said that equation has to be equal to? Okay, is it equal to 0? No. So what would you do on each side?
Subtract 1.
Yep. Now it's equal to 0. Okay. So I want to get ready to plug everything into the formula. Okay. What's A? 2.
X squared.
Yep, the 2 in front of the x squared. What's B?
2.
Yep, just the 2 in front of the x, just coincidence, they're the same. And what's C?
Negative 1.
Negative 1. Okay. What's the first thing I write down as I start to fill into that formula?
-2.
Yep, negative B. Good.
Plus or minus.
Yep, you got a plus or minus.
Square root of 2.
Square root of b squared, which is how much?
4.
4. So b squared.
4 minus 4.
Minus 4, that 4 is from the formula. Times
2.
a, yep, times negative 1, times c. And we're going to divide that all by
2 times 2.
2
So
times
4.
a, which is 2 times 2. Yep. All right, so we got negative 2 plus or minus the square root of. Now we're going to be subtracting a negative.
That's 3.
What happens when you subtract a negative?
You're adding up.
Yep. That's going to become addition, just because it's minus a minus. What's 4 times 2?
8.
Times 1?
8.
Still 8. And what's 8 plus 4? So that gives me 12. And my last step is just to simplify the square root of 12. How can you break up 12 into 2 square roots, and one of them is something that comes out nice?
3 and 4.
3 and 4. Yep. And what's the square root of 4? 2. So let's reduce the square root of 12 to 2 square roots of 3. Now look at all 3 spots, the one on the left, the right, and the bottom. They're all, everything that's not under a radical is divisible by what? 2. So we can reduce that.
Excuse the interruption. This is the last call for any.
All right, so if we reduce everything by 2, how many times does 2 go into 2? Once. And how many times does 2 go into 2 here?
1.
And how many times does 2 go into 4? 2. So what would be your final answer once you reduce everything?
What is square root?
Hold on one second. Question over here.
Just we're going to have pictures again.
Oh, you have to get your picture taken? Okay, yeah, just sign out. You're fine. And we're at the last problem, so I'm going to put the homework up. Yeah, go ahead, William, what were you gonna say?
Square root of 3 over 2. Plus or minus the square root of 4.
Don't forget the -1. So -1 plus or minus root 3 over 2. Okay, so when you do a quadratic formula, if you get a root that can be reduced, you've got to reduce it. If you need help, I can help you. But reducing square roots is something we do. Okay. So, any question on the quadratic formula? Okay, so hopefully nothing new in that section. Maybe just remembering how to do some of that stuff. But hopefully stuff you've done before. So page 89, that's fine. Let me just take a look at 96. Because I might change something. Yeah, 58. So 58 is a word problem that we didn't do. Okay. I think everything else is good. So 35 to 39, that's all break-even point problem. Like find the cost, revenue, break-even point. And then page 96, that's solving the linear and quadratic equations. So we'll go over that. And then tomorrow we will finish up everything for the week. I'll put a study guide on the board so you know exactly what's going to be on the test. And I'll be after school tomorrow. But remember, the test is going to focus on this week. It's not going to focus on last week. And you can make a reference sheet if you want to make a reference sheet.